function composition is a very different way of combining functions from the adding, subtracting, multiplying, and dividing that we may be familiar with. We have as an example a function that represents the expected temperature, we're calling that T of H, for an August 24th day as a function of the hour of the day. So that H represents the hour, T represents the temperature. Then we have another function here that calculates the evaporation rate of a small lake. We're assuming some fixed humidity conditions, so that this is a function just of the outside temperature. Here we have T, little t as our input variable, and big E as our output variable. And the snowman here, who is pretty much doomed on this day, is asking what we expect the evaporation rate to be at 2 o'clock. Well, we can see how to calculate this without knowing anything about composition of functions. At 2 o'clock, the temperature will be 83 degrees. When it is 83 degrees, the evaporation rate should be 20.9 liters per minute. So we're going to go with 20.9 liters per minute. But the point of this application example is that we can see what's going on with composition of functions. The output of our temperature function became the input to the evaporation rate function, so that this is a sequential process. With adding and subtracting functions, we had the same input variable to both functions, and we were just adding or subtracting the outputs. With compositions, the output to one function becomes the input to the next function. So this has to be thought of in a sequential manner. We can now come up with a function here that represents the composition, which calculates evaporation rate as a function of hour of day, and it takes temperature out, right? If we already know the temperature by hour of day, we don't necessarily have to calculate the temperature along the way. So we've already figured out that at 2 o'clock, we're going to be up to 20.9. Now let's go ahead and just fill in the rest of the table. I suggest you pause the video and give it a try, and then just compare your answers to mine in a moment. Okay, so following the exact same process that we followed for 2 o'clock, we get these evaporation rates for our function, right? At 12 o'clock, 68 degrees, and at 68 degrees we get 4.7, so therefore at 12 o'clock we put 4.7. We would follow this process for all of the times given. This is now a numerically defined function that is a composition of the two functions that went into it. So considering that the functions we started with were named E and T, we would call this the composition of E with T, and we would write it like this: E small circle T. That small circle means composition. It does not mean multiplication, so it's not a substitute for the multiplication dot. It's a small open circle, which means composition of functions. We could also call this E composed with T. And to generalize this, we're going to just have a basic way to translate this composition. Anytime we see something that looks like this, F circle G, we think of that as the composition of F with G, or F composed with G. And the way we write it is by putting G of X as the input to the function F. So we write it as F of the whole function G of X. So let's start with a numeric example. I mean, not a numeric example, a symbolic example, but that we're evaluating just at a single number input. So the first thing we do when we look at something like this is we say F circle G, I'm going to write as F of G of that input. And that input in this case is -5. Now I can attack this with order of operations. That G of -5 is inside the parentheses, so I'm going to focus on it first. Over here I'll calculate G of -5. That is 1 over -5 quantity squared, which is 1 over 25. So coming back to this expression now, g of -5 is 1 over 25. I'm going to build the rest of this around that. Still in parentheses, still as input to the function f. Now I'm going to evaluate f of 1 over 25 looking at the function f of x. So f of 1 over 25, f is the function that takes the square root of its input and then adds 3. Well, the square root of a fraction, we know we're allowed to just take the square root of the numerator and the square root of the denominator, so that's pretty simple. And we can either take the easy way out and write this as a mixed number, or if we are required to give a decimal or a fraction, we're certainly capable of doing that also. As a decimal, this would be 3.2. As a fraction, this would end up being 16/5. So again, we see this idea, which we see right over here, of the output of the function g becoming the input to the function f. That is function composition.